Hello, good morning, good afternoon. Thank you all for joining us today for our next TAEC webinar. We're excited to have each and every one of you join us today. We're excited to hear from somebody that's been in the industry for quite a while now. Got a lot of great insight, got a lot of good information. We're excited to hear from Ron. And we're going to I think it'd be great to have Dad give an introduction there. So, Dad, if you take over, and look forward to hearing from you, Ron.
Okay, well, thank you, David. And good morning, guys. I want to introduce you to Ron Moore. I met this guy about 20, let's see, actually, it's been, my goodness, 36 years ago, 1988. And he was, at the time, president of CSI, which I think if you know anything about vibration, they were the leaders for, and still are, really, in the industry now by the name of Emerson. But Ron started the company in 1993 by the name of RM Group, which stands for Reliability-Based Manufacturing Company. And he's been going to senior management throughout the industry, that is, individual plants or corporations, at groups such as SMRP and other groups, plant engineers, and a large variety of people. So we're just thrilled today to having present his reliability-based uh, webinar. And what we'll do is we'll go for about 45 minutes, maybe 50 minutes, and then at the last 10 minutes or so, we'll open it up for questions and answers, and we'll give you instructions at that point about how to enter your questions that you may have. Okay, Ron, I think I'll turn it over to you, and if you will, just take her away.
Okay, thank you. Yeah, we've got a lot to cover, so fasten your seatbelts because it's going to be a quick ride. Yeah, we're going to talk about reliability, and what I want to do is offer you folks a new definition. Now, SMRP, SAE, all those guys, they have definitions, and it's something.
Oh, Ron, I think we may have lost your audio.
Under stated conditions without failure for a specific period of time. And that's a good definition.
Excuse me, Ron, I think we may have lost your audio. Is that true?
Is it a good definition? Maybe, maybe not. So, in a production plant, what does the business care most about? Well, and does
Hmm. Ron, I believe we've lost your audio.
on time, but is that enough? Well, let's look at some data. Now, here's some data from a typical.
Ron, your audio, it seems to be cutting out.
Plant. Wait. So now, what we find if you go look at the data from a typical manufacturing plant is about 2/3 of the
Ron, your audio, I don't think we still have your audio.
yeah, and this thing keeps blinking out. I'm not sure why.
Okay.
Uh, anyways,
When you lean
uh,
forward, it seems to work. There we
okay, I'll lean forward.
go.
Anyways, about 2/3 of a typical plant, 2/3 of the production losses have nothing to do with the equipment. Now, about a third does, but about 2/3 of
Hmm. Seems to have lost the audio again.
I think I lost you for a second there.
Yeah.
Let me try something, guys. I'm going to just cut out for a minute. Okay. Just give me
Okay.
a minute and I'm going to reboot this thing.
Okay, sure. All right. In the meantime, if you're not familiar with TAAC, we're the Technical Associates Excellence Community, and it's a community that we put together about a little over a year ago. And it's our striving thing, that the thing we strive to do is to put together, because of the skills crisis, so many people have been lost to retirement, and people that are leaving the workforce, and that's left us in a real lurch throughout not only this nation, but all throughout the world. And so we're trying to do our very best to combat this skills crisis. And one of the things we're doing right now is holding a series of webinars. And by the way, on January 16, we have our first annual reliability conference that will be held here in Charlotte, and that will be an in-person event. We'd love to have each of you. And we're going to have speakers from throughout. In fact, Ron's going to be one of the speakers, and I will be speaking as well, and as well as about 2 or 3 others. But in any case, Ron, let me turn it back over to you. I believe we do have your audio now. So let me be quiet and turn it back over to you, Ron. Thank you.
Yeah. Well, I'll tell you what I'm going to do. Can you hear me?
Yes, sir. Yes, sir. We got you.
I'm just going to use the computer audio. It's not as good, but it'll work.
Yep. Okay,
Much
sure.
better than cutting out. Anyways, most of the production losses have nothing to do with equipment, and that's where the money is. Okay. So
Right.
I want to offer a new definition for reliability. Now, this is primarily focused on production plants, and I'll come back to some others in just a second. So in a production plant, it's the ability to deliver the maximum in quality product. Now, that's the ability to do that. You'd only make to demand, on time, in full, at the lowest sustainable cost, because that's what the business cares about. And I think OEE is the best measure of process or production plant reliability, because you have to measure and manage all losses. And well, of course, that's what the business cares about. So most of you have seen something like this or similar to it. You measure all your losses from ideal, which would include all your downtime, your rate, your quality, your changeover, and no demand, your market losses. That's market opportunity capacity you have that you could sell, that you can now make. And so this measure is really a measure of your capital efficiency. How well are we using the capital we have? And then you're going to manage the losses. You'll never get the losses to zero, but you want to make sure from a business perspective, they're acceptable to the business. And of course, put optimal use to your capital. So maybe you're not in a production plant. Well, define ideal. It's like an OEE measure. Define the measures that characterize this. Measure and then manage. That's the focus on this. Manage your losses from ideal. So let's look at a couple of other examples. You're at a power station. What do you care most about? Well, producing power on demand at the lowest sustainable cost. So you're likely to care most about your equivalent forced outage rate. And ideal is 0. So you're probably at 4 or 5%. So what's the reason for that? What can you do about that? How are you going to manage that? And in for example, a fossil plant, thermal efficiency is a real big deal. So what's ideal? Where are you? How are you going to manage that? So again, it's measure your losses from ideal and then manage the losses. Maybe you're in a data center. Well, power utilization efficiency matters a lot to you. The power in to the megabytes out. The availability, the energy efficiency. So again, define ideal and manage your losses. Now, then there's some other examples I don't have time to go through, but in all of this, what you have to do is set expectations and standards pretty high, because the lowest standard you set is the highest standard you can expect. So you got to set standards that are reasonably achievable, but challenge people just a bit. Execution has to be excellent. So that means you have to have high standards performed by a highly trained and a highly skilled workforce. And then, of course, engagement of the employees through structured improvement time, management by walking around, and so on. You know, the Gimbal walk, go around and talk to people, find out what's going on and what they might do to help improve things. So, how do we get this reliability thingy? Well, let's first consider some pitfalls and myths. You know, it's common thought that if I install a CMMS, including complete asset registry, criticality analysis, PMs and maintenance plans, comprehensive PDM program, calibration plans loaded, OEM manuals, CMMS linked to stores and so on, linked to cost accounting, a prioritization process. You know, if I do all that and do it well, that's the first pitfall. A lot of these are not done well, and some maybe not at all. So, but if I do, you know, maintenance planning will get better, scheduling will get better, efficiency, stores can be minimized, costs will come down, asset availability will go up, reliability will improve, and everyone will be happy. Well, maybe, maybe not. So let's consider some business issues. You know, here's a quote from Deming that I particularly like. Your system is perfectly designed to give you the results that you get. That is, your business system, your production system, whatever it is perfectly designed to do what it does. So if you're not happy with that, of course, you have to change the system. So now, one thing I like to share with folks is this thing called a market survivor profile. You know, we got three companies competing in a marketplace, A, B, and C. They're selling their products for a particular price that's consistent with the market, and they got certain market share. Now, these three companies, C is the high cost producer. They are compelled to change. If they don't change, they're going to go out of business. Let's look at A. A is the low cost producer. They are driven to change. You know, they know that market price adjusted for inflation for some type of product typically goes down over time. And so they're constantly looking for ways to get better. Little innovation at the shop floor, big innovation at your R&D, your marketing, distribution, and so on, gets financed by the difference between your production costs and your market price. Anyways, the B's of the world, they've been around for decades. They got good products. They're making money. They got a few problems, but they tend to be a little more complacent, you know. Meanwhile, around them, C and A, C is compelled to change and A is driven, and B tends to be a little bit more complacent. Well, one of the things you don't want to be is a B headed to be in a C. What you want to be is a B headed to an A, or better yet, an A. Now, is unit cost over capacity? How much did we make? How much did that cost us? The better guys give a little more attention to capacity, and not in the sense of making it just because you can, but capacity in the sense of what can I do to make sure those assets are fully capable, fully functional, such that I can make to demand. And you do that by getting really good practices in place, having really good designs, good operation, good maintenance practices. You eliminate the defects that result in lost capacity. And when you do that, you can go after more market share with minimal capital investment. And when you do that, your costs come down. Now, the lesson best give a little bit more attention to costs, in particular cost cutting, And that's really a low probability strategy. So cost management is not the same as cost cutting. Costs are a consequence of your practices, your processes. You know, your system is perfectly designed to deliver whatever you deliver at that unit cost. Cost management focuses on improving your practices so that costs come down naturally. Cost cutting is typically not sustainable, but may be necessary in some situations. So now let's pause here. I want to look at this relationship between reliability and safety. And I think it's really important. You know, let me just give you one more comment. You know, most companies out there, safety is a top priority, but is it? Because if you don't have good reliability, you're less likely to have good safety. So here's some data. Here's OEE, big US company. Injury rate on the left axis, that's in yellow. No, sorry, yeah, in yellow. OEE is on the right axis, that's in blue. Now, these are all percentages of some base number. So just have a look at that and see what your conclusion is. Well, my conclusion is when the plant's not running well, injuries are more likely. When the plant's running well, injuries are less likely. Not well, more likely. I've got 6 or 7 of these, and they all follow that same pattern. This next one, total injuries, plotted as a function of corrective and reactive work orders per year. That is, the more reactive corrective work you do, the greater the risk of injury. Now, at that same plant, we also measured PM and PDM work orders. Well, the more of that kind of work you do, the lower the risk of injury. And here's some more data. Here's maintenance schedule compliance plotted as a function of, or injury rate plotted as a function of maintenance schedule compliance. So that just says if your work is planned and scheduled, you're, in reasonable control, statistically, you're less likely to be injured. This next one is production cost, dollars per unit. Now, this reliability index includes design, operations, maintenance, and organizational issues, that it's a holistic picture of how you get good reliability. And of course, as the index improves, your production costs go down. So, and you get a bonus, fewer environmental incidents, higher OEE, and fewer injuries. Now, this next one is data from University of Tennessee here in Knoxville, and I do a little bit of work with them. Here we got maintenance costs on the vertical axis as a function of reactive maintenance. And so, as you can see, the more reactive you are, the higher the risk of higher costs. The next one has to do with injury rate versus reactive maintenance. You get the same kind of effect. So what's the implication of all this? Well, maybe you should have a policy that links reliability and safety. Now, here's a safety policy statement that I literally copied from a company. And just read through this, and then I want to add a word to each of these policy statements. Now, I suspect most of you have something very similar to this, but let's add something to this. All injuries and failures are preventable. No task is so urgent it can't be done safely and reliably. Management must provide a safe, reliable workplace where each is responsible for preventing injuries and failures, and everyone's empowered to stop unsafe, unreliable behavior. See, if I were the boss, this would be the policy, because I want folks, making sure they do a really good job to reduce the risk of injury, but also to reduce costs, improve performance, and so on. A reliable plant is a safe, cost-effective plant. I just showed you the data. So if you truly believe in safety, reliability is a must for operational excellence to minimize the risk of injuries, costs, and environmental incidents. So how do we get this reliability thingy? Well, here's a model. Now, remember, what's reliability, at least in a production plant? Remember, maintenance doesn't control process reliability. It's essential to support it. Think process reliability, the ability of a system to deliver the maximum in quality product on time, in full, at the lowest sustainable cost. And again, OEE is the best measure of reliability in a production plant. So here's the process that I've talked about now for years. The reliability process starts with the design for life cycle cost, then goes through procurement, stores, installation, startup, operation, and maintenance. Now notice, in this model, maintenance is at the tail end. Notice also that most of the defects, and I've got data to support this, most of the defects occur in design, installation, startup, and operation. So maintenance is left at the tail end of this process, and they have to deal with most of the defects coming about because of problems upstream. So it's really important that these functional areas work collectively to a common purpose to eliminate the defects that are creating the rate losses, the downtime, the unnecessary work, the injuries, and so on. So now, just one more comment on this. You cannot maintain your way to reliability because maintenance doesn't control the defects. Maintenance responds or reacts to the defects, but they don't control them, which means you got to get these folks in these functional areas working together to eliminate those defects. Now I'll touch on each one of these as a chapter in my book, Making Common Sense, Common Practice, that covers these in detail, but I just want to hit some high spots. Now, here's a chart of cash flow on the vertical axis and time. Now, I've got some data that says you'd be better off to invest a little longer time and a little more money up front. It's about 10% extra. And you get that money back in the first year of operation. And that seems, and not only that, but every year after that. So that seems to me to be a really important point about investing enough money up front so you get the design that's for ease of operation, ease of maintenance, and reliability. Now, next one is total cost of ownership. This is a purchasing concept. Costs include, well, the standard stuff: price, drawing, selection, effort, procurement, delivery, and so on. The problem is most procurement guys don't consider, at least not very much, the performance capability, efficiency, operability, the maintenance and PM requirements, maintainability, part stocking, service levels. You see, most of the cost of ownership is in those areas, not in the price. In fact, on average, only about 25% of the total cost of ownership is in the price. Stores. Well, let's talk about that for a second. So what parts should you carry? We'll make a list of your critical equipment and then ask yourself, what fails most often? And what parts do I need for that? Well, usually it's belts, bearings, fuses, seals, O-rings, and so on. Well, make sure you have that. Now I ask, what doesn't fail very often, but when it does, it's really serious. Make a business decision about the risk of having or not having the spare and the capital cost versus the probability and consequence of failure. And if it's the consequential cost, including the probability, is really high, then you better have it, better keep it. So, point of all this, you're going to balance the risk of loss in maintenance efficiency and in production versus the cost of capital. So, various domains, reactive, you need lots of spares. You need a boatload. Preventive, because you don't know what's going to happen next. Preventive, fewer. Predictive, that sort of thing, because you sort of have a notion, you've got plans in place, and you detect problems early. But proactive is the best domain to be in, because the proactive domain is where you're eliminating the defects that create the failures and the problems. So, and of course, store staffing consistent with business needs. Depending on the size of the organization, might want to have a night shift to kit the parts and do inspections and so on to make the maintenance function much more productive. So, installation commissioning. Here's some data. Roman Haas, 7 to 17 times more likely during startup incidents are than normal operation. BP, incidents are 10 times more likely during startup. Chemical industry, safety incidents are 5 times more likely during startup. Here's an interesting one. Companies without apprenticeship programs have 5 times the installation startup defects. Wonder why? Well, if you don't have an apprenticeship program, you got a random process for training people through tribal knowledge. So you need a structure that's well thought out, that has the right training and development processes in place, and a validation process. And when you do that, you're less likely to screw up during installation. So anyways, consider the risk of injury, costs, and production losses in this time when you're starting up. So what do we have to do to minimize that risk? Okay, next bucket. Operate reliably. Reliability cannot be driven by the maintenance organization. It must be driven by the operating units and from the top. Now, Charlie Bailey tried to get reliability by focusing on maintenance, and he got some improvement, a little bit, 2 or 3, 4%. It wasn't until he charged the operations managers with reliability, working in concert with the maintenance managers, that he actually started eliminating the defects, getting the right practices in place, and so on, because those guys are working together to eliminate the defects, improve the practices, and so on. And performance improved quite dramatically as a result of that. Another way of thinking about this is to expect maintenance to own reliability. It's like expecting the mechanic at the garage to own the reliability of our cars. Well, you need a good mechanic. I do anyways. But if I don't drive it right, take care of it, make sure it gets its inspections and PMs and all that sort of thing, well, I'm just not going to be as reliable. And my car, I may have mentioned this, is a 1988 Jeep Cherokee. That's the car I drive. I'll be driving it tomorrow to the mountains to go on a hike. And it's got 325,000 miles. Same engine, same drivetrain, and all that sort of thing. So remember, only about 10% of your losses are controlled by maintenance. Most of your production losses have to do with things like changeover rate and quality losses, raw material production planning, blah, blah, blah. And of the 1/3 that is equipment related, maintenance only controls about 1/3 of that. So 1/3 of your production losses are in maintenance control. So to address these issues, what do we have to have? Well, we have to have a good production and maintenance partnership. That's the Charlie Bailey way of thinking. We have to have consistency of operations across the shift. If every shift runs it differently, you're going to get a lot of variation, and that's bad. We have to have good process conformance and capability. That is stability in the process. And we have to have good shift handover. So folks across the shifts are working collectively to run a stable process. And finally, not and not and not least of which is operators taking care of the equipment like they own it. So now there's a lot of detail that's underlying all these things I'm sharing with you, but here's some more data. This is again from the University of Tennessee here in Knoxville. Here's maintenance costs as a percent of equipment cost versus the level of operator care. Level 1 is none, 2 is some, 3 is regular, and 4 is regular PM checks and some repairs. Now, these are simple repairs. It's like a maintenance helper repair. So, which one of those would you rather have? Well, I think it's pretty obvious which one you'd rather have. So, all right. Now, finally, we finally get to maintenance. Maintain for reliability. Maintenance strategy for reliability is the integration of reactive, the run to failure, emergency breakdown, all that sort of thing. Now, my definition of reactive maintenance is anything that broke into your maintenance schedule for the week. Okay, anything. Plus that whatever it is, 10, 20, 30%, you're holding in reserve just in case, because there's no plan for that. You're just holding it back. So that's also reactive, at least in my world. You got a little bit of preventive, time-based, once a week, once a month, once a year. A little predictive, condition-based. In fact, a lot of predictive, condition-based, using all the neat technologies, predictive technologies, plus the operators looking at process and equipment condition. And most importantly, you got a proactive bit. It's defect elimination in all your processes. Now, this model says maintenance is a reliability function, not a repair function. Now, I know you have to do repairs, but you're going to do them with precision and craftsmanship. You're going to put reliability into the equipment. But as we've seen, reliability is not just about maintenance. In fact, quite the contrary, it's about a whole bunch of other things that we do that we just went through. Now, here's some work that I did when I was still at CSI 30 some years ago. And we went out to a bunch of companies and we asked them about their practices. And typically what we saw was something like this, mostly reactive, little time-based, little condition, little root cause-based. And we compared that to 2 or 3 plants that were really, really good. And they looked more like this. That is, most of their work was based on the condition of the asset with a little bit of time-based stuff, a little bit of root cause stuff. And when they did that, they had very little reactive. Now, you will not achieve this without a production and maintenance partnership, one that is production-led. And by the way, this costs you about half as much as that first one. And you get fewer injuries and incidents. So with that in mind, here's a kind of a fundamental question. Does intrusive PM work? Once a year, you tear something apart and put it back together. Does that work? Well, here's some data from World War II from a guy named Waddington. He was tasked with improving the availability of Liberator bombers. Conventional wisdom, the more PM's done, fewer the problems. But when he measured this, here's what he found. Right after a major PM, like an overhaul, aircraft's down for a week, the repairs, the equipment failures in the first 10 hours were really high, and then they gradually disappeared. And then every 50 hours, they go through that again. Then they gradually disappear, and then they go through that again. Well, his conclusion, schedule maintenance tends to increase breakdowns. because it's doing harm by disturbing a stable system. His solution at the time was to increase the time interval between scheduled cycles and eliminate PM tasks that couldn't be demonstrably proven to be beneficial. And he got 60% more availability. Now, we have technology today in the form of condition monitoring that we can use to find out when things need to be worked on, that we should not be taking stuff apart just to take it apart. So, and the broader point here is that most failures are random. This is a histogram of 30 identical components run to failure. So, if you're trying to set up an intrusive PM interval, what would that be? Well, there's no good answer. No matter what answer you give, it's wrong. So how do we manage a random failure pattern? Well, we have to do condition monitoring using the appropriate technology at the appropriate frequency based on failure modes and consequences. Now, here's some more data. Draw your attention over to the right column. These are failure patterns associated with different studies, and this is the percent of equipment in each of these studies that had this. Now there's another set. Let's see, I didn't put it in there. Okay, there's another set that talks about your bathtub curve and so on. But I put this one in here because it's most illustrative of what we've been discussing. That is, 2/3 of equipment has this infant mortality failure pattern. Okay. So when's your greatest risk of inducing defects? Installation and startup. And I just shared that data with you. Then after that, it goes constant. That is, you got a constant conditional probability of failure. In fact, all 5 of the 6 curves in these RCM curves have this constant conditional probability of failure associated with it. So how do you manage that if most of them have that? Well, it looks like this. First off, that is, the probability of any one of these failing is the same as the probability of any other one failing. And the way you manage that is by doing condition monitoring at the appropriate frequency with the appropriate technology. So, predictive maintenance, it's condition based. Yeah, all the neat technologies that I used to sell, and appreciate your business and all that. But I think most importantly, it's the operator. You got 5 or 10 times as many operators as you do maintenance techs. So you better have those guys be looking at the process condition, the equipment condition, look, listen, feel, smell, and so on. In fact, Charlie Bailey's company, 83% of their condition monitoring tests were done by operators. 17% done by predictive maintenance techs. So what are we doing with this? Well, we're trying to understand the degradation process so we can avoid or minimize the consequence of failure. So right here we have onset of failure, but we don't do anything because we didn't detect it. Here we detect a potential failure, but the system is still meeting all my requirements. It's just making a noise, wee, wee, or some such thing. Here we have a functional failure. System is not meeting all my requirements. And that window, that PF interval, is the time I have to take action to minimize the consequence of failure. And I sure want to stay out of this last one where it crashes and burns. Now, one other thing I would encourage everybody out there to do is be proactive. That is, you want to go back before the onset of failure and do the things that stop the defects that can create the failures. So that's a very much of a proactive way of thinking. And here's some data. This is from John Schultz at Allied Reliability. Here we got maintenance costs as a percent of equipment on some sort of condition monitoring program. So it's pretty obvious. The more you do that, lower your costs. But, real important, but you have to act on what you find. So you better have good work management, planning and scheduling, and you better be proactive to stop the defects so you don't have to detect as many. Now, from that same study, This is percent PM work. So beyond about 20, 30% time-based work, your costs go up dramatically. Well, why is that? Well, because you're doing unnecessary work. And in some cases, you're intrusively imposing yourself on the machine and inducing defects. And when's the greatest risk of failure? Right after that, when you start up. So you want to be really careful about doing intrusive PM. Most of your PM should be inspections, lubrications, filter changes, calibrations, all that sort of thing. And only when you have a known, consistent wear-related failure mode do you do intrusive stuff. So now, don't assume that your PM is correct. This, again, is from John Schultz. He looked at 20,000 PM tasks and concluded about 10% of them you could delete. About a third of them you could replace with condition monitoring or re-engineer or transfer to operations or have a dedicated lube function. And about 10% use as is. Well, golly, 10% use as is. That's not very good, I don't reckon. Now, planning, then scheduling. Now, planning requires a proactive approach to defect elimination. That is, your planning process will fail if the total number of defects overwhelm the planning system. You know, you got all these plans set, and every morning you come in and something's happened, and you just throw them out. So you got to stop the defects that are creating all the work. You should have one plan. It's called a production plan. It includes the maintenance plan. They're one plan led by production. And both production manager and maintenance manager are held accountable for that. And again, schedule 100% of the workforce available, but allow for breaks to the schedule. Some people don't want to do this. I recommend strongly that you do. Two things will happen. One is you'll get more work done because people expect to. The second thing that happens, though, is that you'll make better decisions about what breaks into the schedule. Yep, you'll get more work done, you make better decisions. So let's see, what tool when? I'm going to, just in the interest of time, I'm going to jump right through this real quickly. I would start with the basics, you know, things like 5S, standard work, go and see 5Ys, visual workplace. You can, these are the organizational enablers. They create the discipline, the readiness, and they involve 95% of the employees. And then you go down through some TPM stuff, and then you get down to the more advanced tools. Now, some of you may not think these are particularly advanced, but compared to this, they are. So the problem with starting here is if you don't have the organizational readiness and discipline, these won't be sustainable. And I could talk for half a day about this chart, but I don't have time for that. Okay, coming down the home stretch, let's talk a little bit about leadership, organizational alignment, change management, and so on. Excuse me. Leadership is the ability, in my world, the ability to inspire ordinary people to consistently perform at an extraordinary level. Now, I don't mean ordinary people in a pejorative sense. I mean regular folks doing a superior job because you put them into superior systems. You create the environment for that. And it really begs the question, how do I get people to look forward to coming to work? We'll give them work they like to do. Put them on the improvement team. Go talk to them. Send them to a training course. Make sure they use that. You know, it's active engagement with your people, because that's where the leverage is in your success, is your people doing a good job every day. Level 5 leadership, and this is from Winston LeDay, floats to the person best qualified to eliminate the defects. That is, the nature of work determines who is in the lead position. Types of leaders: executives provide the vision, resources; operational leaders provide the time, and the shop floor leaders provide the ideas for improvement. And this is a mantra that I live by, or try to. If you want to understand the problems with the work, talk to the workers. Such an obvious thing that not enough people actually do. Most organizations are not aligned. Just read through this right fast. Now, consider the consequences of this if you were a coach and your team's athletes felt this way. See, align the organization. And here's a real key point. As task interdependence increases, teamwork becomes critical for organizational success. So you have all these task interdependencies between production and maintenance, between shifts, between maintenance and stores, and so on. All this task interdependence, which means you need to work together to eliminate the defects for greater success. Alignment requires the creation of superordinate goals that take priority over group interests. So you got to have partnerships agreements and shared measures between competing groups. And you have to think at a systems level. That is, don't optimize at the suboptimal level in your little silo. Managing culture. That's what people do when the boss isn't around. So managing culture or change, compelling reason for change. Communicate your strategy, goals, and roles repeatedly. Apply leadership and management principles. Leaders want change, managers want stability. Well, you have to do both. It's the opposite sides of the same coin. And the most important one, facilitate employee implementation of the change process. People own what they create, so they have to be a part of the creative process. Measure the results, reinforce good behavior, challenge bad behavior, and stabilize the change with procedures, standards, checklists, all that sort of thing, and then repeat the process. Managing cultural change isn't something you do once and it's done. It's something you do every day, forever. So people don't want to change. You hear that a lot of times. People are stuck in their bad old ways. Well, see, I disagree with that. I think people do want to change, but there's some caveats. If given compelling reasons, if there's something in it for them, more secure future, less risk, better pay, and if they participate in making the changes, and that's the most important one up there. So you got to give them a compelling reason. It has to be something in it for them, and they have to participate. All three ifs must be addressed. And stabilize the change, procedures, standards, checklists. If the change takes longer than executive or organizational attention span, it is doomed to failure. Constancy of purpose is essential. That's another Demingism. So a little bit about performance measures. They have to expose our weaknesses. OEE is an example. They have to facilitate collaboration, not conflict across functional boundaries, particularly in groups with high task interdependence. And it must matter. Used to drive behavior. Have to be limited to our span of control, be visible and displayed and kept current so they appear to matter. And most importantly, have the right balance of leading indicators, that's shop floor stuff, the things you do, and lagging indicators, that's the results you get. Strategy for implementation, real quickly. Has to be led from the top. Executive sponsorship is essential. 3 to 5 years, not months. No low-hanging fruit. Well, there may be, but that's not how you're going to get operational excellence. You have to have a good production and maintenance partnership. There have to be shared performance measures so that facilitates the collaboration, the teamwork. And there has to be a shop floor engagement process, including cross-functional teams. And you want to make sure people understand the link between safety and reliability. So engage the entire workforce in eliminating small day-to-day problems has a much bigger impact on results than focusing on the major failures. Well, it's a bit of a surprise to some people. Engaged employees are 3 times more productive. Nothing changes until the shop floor does things differently. Differently as in better. Now here's a kind of an example of this. You got 10 guys on a boat, okay? And they're rowing. Now only about 30%, 3 of them are engaged. That is, they're tugging hard on the oars. 50% are disengaged. That is, they're sightseeing. And 20% are actively disengaged. Right? They're trying to sink your boat. So a real quick couple of summary slides. I've got more, but I don't have time to cover them. Your system is perfectly designed to give you the results that you get. So with this kind of information, what are you going to do to change the system so that it gets better? And finally, I think process reliability. That is the ability of a system to deliver the maximum quality product on time, in full, at the lowest sustainable cost. And like I said, OEE is the best measure of reliability in a production plant. And what you have to do is measure and manage the losses. Okay, so what we otherwise would do is we don't have time, but you can take this home, list 3 actions you're going to take to assure operational excellence, a safe, cost-effective, reliable operation. So that concludes a really zippity-doo-dah rapid presentation. So, okay.
Yes, sir.
Okay.
Thank you very much for that. I'd like to open up the floor.
Or comment, whatever it may
any kind
be.
of questions or comments you have for Ron or anybody here. We can unmute you and you can ask a question or you can put it in the chat. So anybody have any questions for Ron or for anything? Thank you, Ron, for that information. It's good stuff for sure. So
yeah, it was awfully quick. I sent you a copy of this, didn't I?
yes. Mm-hmm.
Yeah, you can share it with folks. I don't mind that.
Okay, perfect.
We're going awfully quick through that. Not much time to pause and absorb and think.
Yeah, not a problem. Yeah,
there's a lot of tremendous information. Tremendous information, Ron. Really excellent. I was wondering, when you get into terminology, when you get into some of the things through which you went, that you covered, the Kaizen effect and the things that Charlie Bailey shared and so forth, is that all contained within your book that you have?
Yes. This is a very high level summary of the making common sense, common practice.
Right. Yeah. I learned about the book there at SMRP and it sounded very fascinating. And there was a tremendous response from the people as well. Everyone was locked into what it is that you were saying.
Well, just remember now, the book, you got to want to read it. Okay? It's not a novel.
Oh, no, huh? Okay.
It will help you go to sleep at night.
Oh, yeah.
You know? So
that's good sometimes. Let's see here. I'll check the chat. Any other questions? We had somebody thanking you for presenting it there. Don't see anybody raising their hand either.
See Mike Barkle. Hey, Mike, you want to put in here?
Let's see. All right, I'll wrap up here for us. I'll make sure that y'all know this is the next TAEC event, like Dad said earlier, will be our first in person. We're excited to be hosting here in Charlotte, January 16th of 2025. It's a Thursday. So we'll have a couple speakers. Ron actually will be one of the ones speaking. And so yeah, Ron's gonna be speaking. Dad will. There are a couple other guys coming in, and gonna be a good group of people coming in. Hopefully, get a lot of y'all to attend, and your friends as well. So register online for that on our website, and several things are included with the registration, including t-shirts, stuff like that. So we're just excited to.
I'll be covering the same material, except I'll hang about and, allow for, more comprehensive discussion than what we
Sure.
had today.
Yeah.
Yes. Yeah, similar to what was at SMRP when we had a personal event, and Ron makes a real impact. I know that occurred up in Nashville at AB Tech, and it was very useful. And another thing, as far as the conference is concerned, too, this will be for any and everyone that's involved in any case with reliability and management, the shop floor people. As we just learned today, the production people. Everyone's involved in putting together this entire cultural change that's necessary for us to combat the skills crisis, which is our driving passion. So, any other questions or any other comments to be made?
There's the date there, January 16th. So, if there's no other questions, we're thank you very much for joining us today. I know that it took y'all's time, and took Ron's and the rest of us time to prepare for it. We're just excited to continue to share information and to do what we can to help with the skills crisis, and just to really kind of continue to build this community. We're excited to have each of you join us today, and thank you, Ron, for sharing your wisdom, and we look forward to seeing everybody in January.
And by the way, for January also, I just want to go ahead, Ron. Go ahead.
I said I'll hang about for a minute if you guys want to, do some closing discussion.
Sure, absolutely. And also, guys, I wanted to make you aware that we'll use social media, several different platforms to use, also things like email to make sure that each of you know about January 16. It will be, like I said, the first reliability event for us, the annual event that we're going to be putting on. So we want to invite each and every one of you. Okay, all right, David, I'll turn it back over to you.
All right. Well, that concludes our event today, and thank you very much for joining. So, look forward to seeing you in January here in Charlotte.
Thank you all.
All right. Thank you.
Bye.
Bye-bye.
Thanks, guys.